Hi, we're going to be looking at addition and subtraction of unlike fractions today, which simply means we're going to add and subtract fractions that have different denominators. And we'll do a quick review of adding fractions with common denominators. So as you recall, if we had 4/5 and we added 3/5, well, let's see, when we have some fifths and we add some more fifths to that, we're simply going to get more fifths, right? Of course. So our denominator stays the same, and all we have to do is add the numerator. 4/5 plus 3/5 is going to equal 7/5. When we look at our answer, we notice that it's top-heavy, which means we can pull out some whole numbers from this fraction. We know that 5/5 is a whole number, so we can take away 5/5 from 7/5, and we've taken away a whole. After we take away 5/5 from 7/5, we have 2/5 left over. So, as we look at this, 4/5 plus 3/5 is equal to 1 and 2/5. So that's our quick review. And now we're going to look at fractions, adding and subtracting fractions with different denominators. So let's see if I can grab this piece right here and look at it with a little bit of manipulatives. We're going to look at, let's say we have 1/3, and we want to add 1/2 to that. Well, let's see what that looks like first of all. We're going to grab 1/3 over here, and we'll grab a half over here and put it together. Now, realistically, it's going to be difficult to tell exactly how much we have. Do you know why? And that would be correct, because we have different denominators. When we have different denominators in our fraction, we can't exactly tell all the time what we get. So, do you know what we need to do? I'll bet you do. I'll bet you know that we need to make some common denominators, don't we? So let's go ahead and find some common denominators. Before I do, I want to cover up, well, I tell you what, let's go ahead and decide first of all what would be a good common denominator to use for thirds and halves. In other words, it's going to be a multiple of 3 and 2. We could choose the LCM, the first common multiple for 3 and 2, or we could just choose a common multiple. So I'm going to go ahead and use their first common multiple, and I'm going to choose sixths. And I'm going to rewrite this equation underneath, and I'm going to get ready with sixths as my denominator. I haven't changed the fraction totally yet, but let's go ahead and look at that first of all with some manipulatives. And let's go ahead and bring all of this over and see what we've got. All we need to know is, what does this equal in sixths? So I'm just going to cover it up with some sixths. And as you notice, this is a sixth over here. We had 1, 2, 3, 4, 5, 6. So I'm going to take these pieces one by one, move them over, and see if we can cover it up. Before we figure out the answer to this problem, there we go, let's see what we have. Okay, it looks like our answer should be 5/6. So let's go ahead and see why we got that. Let's put the answer here. Let's put it in green. So I know my answer is going to be 5/6 because I just did it with some manipulatives, but let's see why. Well, we started over here at 1/3 and we changed our 1/3 to 6. What did we do to our denominator here? I can't really mark right here, it's not letting me. What did I multiply my 3 by to get to 6? That's right, I multiplied it by 2. And why is it not writing for me? Let's say we multiplied that by 2. So if I multiply my denominator by 2, what do you think I need to do to my numerator up here? That's right, I need to multiply it as well by 2. So 1 times 2 is going to be 2. And again, it's not going to let me do very much, so let's try that again. That's a 2. So I've changed my 1/3 to 2/6. Now I've got to go to my other number. Do I multiply it by 2's as well? No, of course not. We can't do that. We need to make sure we figure out what it was that we did to our denominator. Our 2 over here was different. We didn't multiply it by 2. What did we multiply our denominator here by? We had to multiply it by a 3. So if I multiply 2 times 3, what do I need to do to my numerator? I multiply it by 3 as well. Whatever I do to one side, I need to do to the other. Whatever I do to the denominator, I can do to the numerator. So 1 times 3 is 3. And so 2/6 plus 3/6 becomes my new equation. I started with 1/3 plus 1/3 plus 1/2. Now I have 2/6 plus 3/6, and that is how we got 5/6. Got it? Okay, let's see if we can go ahead and try. Let's go ahead and insert a new page. And you try a couple. Let's see how you do. Let's go ahead and see if you can do 3/8 plus 1/6. Now, before you get started, I'm going to say that it's going to be really important to rewrite this equation. Don't do this in your head. Don't just put an answer. You aren't going to be able to add 3/8 plus 1/6, right? You've got to change them to common denominators. So think about what is a good common denominator for 8 and 6. In other words, what's a good multiple of 8 and 6? You could look for the first common multiple, the least common multiple of 8 and 6, or it could be any multiple. It's just that the least would be the easiest. So you can go ahead and pause the screen and solve this problem and come back in just a moment and let's see how you did. Have you paused it? Good job. Well, let's go ahead and work this problem out and see how we did. I'm going to get started by rewriting this equation, and I'm going to decide I could list out my multiples for 6 and 8 and find that the least common multiple is 24, and I think I'd rather use that than a larger multiple, just because it's going to make my job easier, and that is not a pretty 4. And so then now I'm going to come over here and put another 4, 24. So now my denominators, I have common denominators now. They are 24. So now I need to figure out what my numerators would be. So let's go way up here and decide, first of all, what did I do to this 8 to get to 24? That's right, I multiplied it by 3. So, of course, that means I need to multiply my numerator by 3, which now means I get 9. So 3/8 and 9/24 should be equivalent if I did that correctly. And then I come over to my second fraction and I decide, how did I go from 6 to 24? Well, that one was times 4, which means, of course, I multiply my 1 times 4, and I'm going to get 4 as my numerator here. So 1/6 and 4/24 would be equivalent as well. So now I'm faced with 9/24 plus 4/24, and I get to just add those. So I'm going to have 13/24. Is that the answer that you got? Well, very good. Before you decide that this is the end of the road, that your problem is complete, you have to make sure that this fraction is fully reduced. So you have to decide, is there any number greater than 1 that can go into 13 and 24? Since 13 is a prime, the only factors it has is 1 and 13. And 13 does not go into 24. So this problem is reduced, and that is the final answer. So let's try one more. Let's go ahead and erase this one. Takes just a little while to erase. And try one more. Let's go ahead and this time let's subtract 1/6 from 7/8. Of course, that wouldn't be the way that we would write that problem, would it? We would say 7/8 minus 1/6. So if we were going to subtract 1/6 from 7/8, once again we need to find common denominators. Subtraction works the same way as addition. You're going to need to rewrite your equation with common denominators, only this time instead of adding, you're going to subtract. So go ahead and pause the screen, try this one out, and come back as soon as you're ready to see how you did. Okay, are we ready? Once again, I'm going to rewrite this equation. This time I'm going to make some common denominators for 8 and 6. And once again, how did I do that? I got a problem again with 8 and 6's, but we already know that the LCM would be 24 for 8 and 6. I should have chosen a different problem, shouldn't I? And of course, we already know that 8 times 3 is 24, so I'm going to do times 3. And up here, I'm also going to do times 3. Where did my pen go? There we go. And so 7 times 3 is 21. So 7/8 is the same as 21/24, so I'm going to subtract these two, and then I'm going to decide how did I get from 6 to 24? Well, that was times 4, and so of course I'm going to need to do times 4 up here as well. And so 24 1/6 is the same as 4/24. So 21/24 minus 4/24 is going to leave us with, let's see if I can do this, 17/24. Once again, 17 is a prime number, and since 17 does not go into 24, we are finished with that problem as well. So let's go ahead and do one more, just because we did one that was comparable to the other with the denominators. Let's try, let's see. How about 7/10 minus 1/6? Go ahead and pause the screen. Come back as soon as you're ready. And what's a good common denominator here? I think 30 would work. And of course 10 times 3 is 30, so I'm going to put a times 3 here, if it lets me pick up my pen point. And then I'm going to go times 3 here. That's going to be a 21 here, minus, and 6 times 5 is 30, so I'm going to do a times 5 and a times 5 up here. So I'm going to subtract 5 from 21, and that's going to be a 16/30. And finally, we have a problem that needs to be reduced. I know just by looking at these two numbers that 2 goes into both of them, so I'm going to divide both of these by 2, and I'm going to get 8 over 15, and I'm going to sit here and decide, is there a number greater than 1 that goes into both of these? Well, I know that 8 is divisible by 2, 15 is not. I know that 15 is divisible by 3 because 5 plus 1 is 6, but 8 is not divisible by 3. 4 will work on 8, but it doesn't work on 15. 5 works on 15 and doesn't work on 8. 6 will not work because 2 and 3 did not work. And now I'm on 7. 7 doesn't work and 8 doesn't work. That means that there is not a number greater than 1 that goes into both. I am finished. You are finished. We are finished. Have a great day. We'll see you next time.